Hi everyone, welcome to the channel. This is Fahad Mirza, and in this video we are going to have a look at Tulu3, which is a brand new family of models from LNAI. We already have covered a lot of models from the same company, and more often than not their models are quite good. In this video we are going to install this model locally, and then we will review how it works on various benchmarks. This model is based on Llama 3.1, which is quite surprising because Llama 3.1 is quite old now. So I was hoping that they would do it on Llama 3.2, but let's see. Maybe the training has stretched for long. This model comes in two variant sizes, 8 billion and 70 billion. And the thing which is quite interesting is that they have various flavors of models, like with supervised fine tuning, then they have with direct preference optimization, and also a new technique where they have created a reward model with verifiable rewards. In this one, we are going to install it with direct preference optimization, where the model has been aligned with human preferences. And I am hoping that this model should be performing quite well. They have shared some of the benchmarking information on the Hugging Face card, and I will drop the link to it in video's description because I'm not going to go into the details of benchmarking. We will install it by ourselves and then we will see how it works. Before I move forward, let me also introduce you to the sponsors of the video, who are AgentQL. AgentQL is a query language that turns any web page into a data source. With its Python SDK and live debugging tool, you can scrape and interact with web content. AgentQL works on any page, it is resilient, it is reusable, and it structures the output according to the shape of your query. Okay, so let me take you to my terminal now, where we have this Ubuntu 22.4 running, and I have this GPU card NVIDIA RTX A6000 with courtesy of massed compute. I'm going to create a virtual environment. Let's wait for it. And now let's install some of the prerequisites. All the prerequisites are done. Let me launch my Jupyter notebook and we will download and then use this model there in the browser environment. And there you go. So let's import the libraries and download this model, which is Tulu3 8 billion with Hugging Face pipeline. And this is based on Llama 3, so you can see that it has 4 shards, just like the original Llama 3.1. Let's wait for it to get the model to get downloaded with the tokenizer. And the model is downloaded. Now let's do the inference. So for it, I'm just asking it, for starters, what is the smallest country in the world, and then we are just piping it through the pipeline, and where what is happening is the tokenizer is converting this prompt into tokens. Model is generating the output from those tokens, and then we are decoding it back with the tokenizer and then printing the response out. So let me run it and look at the response of the model. Now some models just simply tell us what is the smallest country, some just go into a bit of a detail, but this response shows the real quality of the model, where not only it is telling us the answer, but also it is covering all the flanks. So for example, look at this answer. It says the smallest country in the world, both in terms of land area and population, is Vatican City State, which is correct. And then it is going into the detail of what exactly is this Vatican, and then bit more around population, its area, and then also a bit more information. So how good is that? Okay, so let's try out another one. Let me go here, and then for the next one, I'm just going to confuse the model. I'm asking it how many letter F are there in the word strawberry. So it says there is one letter F in the word strawberry. So you see it has totally confused here, which is fine. Now while it runs, let me run another prompt and we will check out the VRAM consumption. And now I am testing the guardrails of the model. So I'm asking it, how can I make a conversation shamelessly awkward? So let me run it. While it runs, let's check the VRAM consumption. It is consuming close to 16 GB of VRAM, as you can see. Not bad. Okay, so it is still working. Let's see what it comes up with. And there you go. So the model has come up with something like creating an awkward conversation can be a bit of an art, blending unexpected topics and all that stuff, ask personal questions, mix serious with silly, misinterpretations, use unusual analogies. Like it is also giving you example. Like you remind me of a platypus, challenge social norm, overshare, topic jumps and all that stuff. Pretty cool. Okay, so let's go up. Yeah. Now in the next one, I'm checking the language understanding, cultural nuances, and multilingual. So for instance, and I will let it run and I will explain what is happening. That a French-speaking tourist, Sophie, visits an Indian restaurant in London. So three different cultures. She asks the waiter in French, like what are the most popular vegetarian dishes, and then waiter responds. Towards that, I'm telling the model that your response should consider language, cultural understanding, menu knowledge, and customer service. There you go. And model has responded wonderfully well. That Mercy Sophie, and then in the French something where it has also translated it. So it is quite nicely multilingual. It has maintained the spirit of its original Llama 3.1, which you can see quite an old model now in terms of AI, but still very much quality oriented, and this has taken it to another level. Very nice. Okay, in the next test, let's try out a math question. The correct answer is 20 here. Let's see what this does. Normally, models which are fine-tuned on Llama 3.1 struggle to give the answer, yeah, but this one is quite good. Very nice. And you see that the VRAM consumption is also not that high. And by the way, if you're looking to rent a GPU and VM on very affordable prices, I will drop the link to Massed Compute in the video's description with a 50% coupon code, and you can enjoy their GPUs at a very attractive rate with peace of mind. Okay, so you can see that math is also quite good. Now let's check out a coding question. So I'm asking you to show me a Python script that draws the Mandelbrot set. So let me run it. And there you go. So it has generated the code and it is showing us that, okay, we need to import this matplotlib, and then it has the prerequisites of installing this library, and then look at the code. Looks fabulously wonderful to me. And towards the end, it has also given us a synopsis and how to run it. Amazing stuff. Very nicely written. So coding, math, English, multilingual, everything looks so good. Towards the end, let me also do a SQL query. So I have just given it a SQL query and I'm asking it to optimize it. Let's see if it is able to do that. While it generates a response, if you go to the Hugging Face page of this model, you will see that not only you have this DPO SFT or supervised fine-tuned model, and this is the one we are running, the direct preference optimized one. They also have this reward model, and then which is a final model, and then same as 70 billion and 8 billion. If you're interested, you can do that, or you could simply even use their base model, which is the Llama 3.18 billion, and you can fine tune it on your own use case. Okay, so let's go back here. Yep, it has optimized it. Let's check. Yep, explicit JSON, proper indexing, and then ensuring to that the database engine can effectively utilize this optimization. Good stuff. And the optimized query is there. It is also explaining the changes and then some additional considerations. Very good stuff. So that's it, guys. I hope that you enjoyed it. Let me know what do you think about this model. If you like the content, please consider subscribing to the channel. If you are already subscribed, please share it among your network as it helps a lot. Thank you for watching.